Hello, everybody, and welcome. Happy Monday. Hello, Michael. How's it going?
Hi, Alex. Good to see you. Yeah,
Good to see you.
it's good. I think we will have a fun episode today. So in preparation,
Good.
I ran into some really interesting challenges. So let's see how far we get and
Okay.
how it will be going. No, otherwise, sun is shining. Weekend was good, and hope you're feeling better this week. And last week I had to do it all by myself, but I was really brave and went through it. But it's much better to have you on my
Yeah.
side.
Yeah, I watched
So
from the sofa. I didn't feel
hope you're feeling
that
better.
good. Yes. Still a little coffee, but that's I think manageable. Hi, Eshwar. Thank you for joining. Thank you, everybody in chat for being here live with us on this Monday morning, evening, or afternoon, depending on where you watch this on the globe. Yeah, it's a fun episode. Michael already mentioned it, so let's see. I mean, when you mentioned it to me, you would like to do. Are we going to do Tree of Life? Is this what we're going to do?
Yeah, let's
today?
try it. Yeah, so that's what we're gonna try to do.
So
let's see.
Yeah. Okay, cool. You mentioned Tree of Life, and I was thinking, I don't know. I don't quite know what does he mean. Is it like the actual, the species and how they're related? And I googled
Exactly.
Tree of Life, and obviously one comes back is some weird responses.
No.
But yes, I thought this is what you mean. Hi, John.
Exactly. So actually, there's quite some Neo4j involvement in the Tree of Life, and I thought. I was actually thinking on the weekend about the data set that we could use, and I was thinking about like being in a park and having all the species there, all the trees and insects and everything, and spring is coming, and I thought it could be a nice one. And let's see how far we get, because the data is pretty big, and so that's the bigger challenge to see how to get it in there in a good way. But at least we can look at some examples and basically use those examples to show you how you would do it for real if we don't get to it. Right? So let's see how it goes.
Let's do that in a moment. Right. I'd like to mention the final episode of the Neo4j training series taking place next week. So this week we take a little break. The past 3 weeks we did From Intro with Michael, Intermediate Cipher with Adam, and last week we did Building Routing Application with Will. All very interesting sessions. They are all available on YouTube. So if you missed them, check out the YouTube channel youtube.com/neo4j, and you find them there. And next week is Spring Data Neo4j with Garrett. So if you're interested in Spring Data Neo4j, if that is something you want to know more of, learn a little bit, get some, beginners.
Yeah, or Java development in general, right? So because
Java
many of those, many of those translate also to other Java frameworks as well, right? So
of course, yeah. So if you want to do that, if you want to see a little bit of that, how app development exactly, like Michael said, goes and works with Neo4j, then this is your session. It's happening on the 12th of April, so in a week, next week, on the Wednesday, and so that's that. Please, come around if you wanna. Good. And then hands-on with Neo4j, AuraDB free. So Michael mentioned it. We will talking about the Tree of Life today and see where we get from there. What we generally do is we pick a data set and work with it and then have some fun with it. If you have some suggestions, this channel is always open. So if you see something somewhere, let us know, and we might be able to include it in one of the next episodes. And have fun with your suggestions. So that's your invite. And what do we do in general today? We try and see where we're going. So I guess we'll see how far we get. But generally, AuraDB free gives you a free Neo4j database as a service offering. You just need to register for it. It stays with you as long as you like it. It won't go away. It might be paused at some point if you don't use it, but you can always go back and restart it. So that means you don't have to worry about your data getting lost or anything else. So that's not the case if you were using Sandbox, for example, in the past, or are using Sandbox now.
Yeah.
AuraDB free is a good alternative if you want to have some more long-term baseline where you can work with your data and work with a graph. You get Enterprise Edition, you get 200,000 nodes and 400,000 relationships, so that should get you going pretty far. And then you can always upgrade if you like. And you get Neo4j Bloom, as well as browser and data importer in the new workspace look and feel as a user interface, which makes the launch and the start and the get going super easy. Maybe not this episode, but in a couple of the previous ones, you could see us work literally with no code at all, no code necessary at least, from a data set via data importer into Neo4j Bloom, into your first graph visualization, and you just don't have to use. You have to know one single line of Cypher you have to write. You just, the program helps you that much, and the tool and the guiding. So it's really easy. And you can see today. Well, we'll see how far we get. Hopefully, we get from graph.
Exactly. Yeah, exactly. Let's see.
All right.
Cool. And with that, let's have a look how far we get. So Alex just mentioned that he Googled basically Tree of Life and Neo4j. So if we do this, let's see if we do Tree of Life Neo4j. You see there are quite a number of links there, right? So graph database Neo4j is the root of Tree of Life. Basically traversing the Tree of Life using Neo4j from Priya. And then Tomasz also did traversing, analyzing the evolution of life on Earth with Neo4j, right? So there seemed to be some prior art for doing that. And I actually, unfortunately, underestimated the sizes a little bit, to be honest. But we can look at some of the examples and see where we go from there, right? So the most interesting project is actually the Open Tree of Life, which is an open project that runs on top of Neo4j. Which basically has imported, has passed all the different nomenclatures and taxonomies, brought them all together from all the different species and genuses, or is it genuses or genii? I don't actually know. Of all the families and all the plants and animals and insects and spiders and everything, right? And what they did is basically they published this both as an interactive UI, which is this one, where you can basically navigate in the Tree of Life and then say, hey, I start at cellular organisms, go to bacteria, and then within the bacteria, then I can go into more detailed levels as such as well. And then from there, I can go all the way down to a certain bacterium, basically as such, or I go back back to the animals and then go from there. So they basically have all this data in Neo4j, and then basically you can drill down, you can search, you can get taxonomy information, you get other names and spellings and other things as well. So there's a lot of detail there, right? So and drill down and so on. So it's pretty cool, right? So, and then they also said, oh yeah, we also have an API here, API documentation. So I thought, yeah, cool, let's take the API. Actually, what they wrote here in this article is that they changed their pipeline to a C++ library, and this is much better, of course, but it also makes it only somehow harder to access this data. It would be nice to have just a dump in CSV also to get it in. So they seem to have a more complex pipeline setup.
Maybe the CSV file is getting too big now.
Yeah, probably. So they say, well, then just look at the API docs, and we can basically just go to the API docs and try this. Unfortunately, I'm not really sure what happened here, so it's a little bit older, but I couldn't make this API work somehow. So I don't know. So I tried to use this, but it didn't really work. So I don't know what happened there. It's still live, but it's basically somehow, we need to look into that. But at least it's a practical application. So there's also some news articles about this here. Graph database Neo4j is the root of tree of life, and which kind of explains this a little bit. There's also a video that goes into more detail, similar to our live streams as such. So that's nice. Here's also like even an Huffington Post article talking about this, and you see basically an circular diagram of all the different species, basically, right? You have all the metazoa, like all the fungi, then archaea, and then somewhere in there are like the humans and the animals and so on, right? So there's 8.7 million species on the planet, and many that still have to be cataloged if they're not extinct by the time that we get there, because humans kind of killed off all life on the planet. Okay, so that's kind of what we could have used, but somehow the API didn't really work out. So okay. Then there is Priya's article, which is really interesting, where she basically found a Tree of Life web project, which has a ginormous, it has an endpoint for certain tree structures, basically. And you can say, start at this node ID and then give me basically all the tree from here, right? So basically, if you open this page with curl or on a web browser, it downloads 230 megabytes of data, I think, or something like that. So it's quite a lot. So you can see, where's the Tree of Life? Life. There, put it. Here, Life on Earth. So it's 208 megabytes of data in XML, right? So so it's a ginormous XML file that is pretty big. And I just tried to load it into my local instance of Neo4j, and it's a little bit struggling to import it all and quickly. But what it basically does, it takes the file and then turns this into species that are connected with each other, get some name set and so on. So my idea was I can import it, but I started a little bit late, so I thought it was much smaller. So I started a little bit late, but what we could probably do here, if I abort this and we run this in a smaller size, let's say we load this XML and we basically take, where does it stop the with statement? It starts here. Description, extinct, ancestor ID, synonyms are here. Yeah. So if you limit this, let's say to 20,000 or something like that, right? So it should only give us like the first 20,000 entries from the XML file. And if I run this and restart my server, but I think I died of an out of memory exception. I need to see why it actually didn't complete it. 1 second.
Well, you just stopped it, right?
Yeah, it just stopped. Yeah, so but now let's see. So I tried to do the whole file, so which was a little bit too much. But the basic model is pretty straightforward, right? So we have species, and I think I might even have misspelled the species. Actually, it's species, not species. Okay, let me do this. So server started again, so we should be able to connect. Let's see. Okay. So you see, I actually miscreated the constraint. Yeah. So there is, it's not called species like I called it, but it's called species. Create constraint for, and then species require s.id is unique, and I hope I didn't misspell it. Okay, now we have our constraint. And we can try this again. And because you only do 20,000, it should hopefully work quicker. And then we get the data into the graph. Right? So, but what it does is basically it extracts the data from the XML, kind of filters some name description fields out of it, ancestors, if the animal or the being has been extinct, and then basically for each of those creates the species, that's the name, that's the description, that's the extinct case, and then synonyms, and then basically finds the ancestor and then connects the ancestor basically to it, right? So let's see if you can get this to work. Right, so the model is pretty straightforward from that perspective. Okay, that's our second attempt. And our third attempt, and then Priya has a number of interesting queries on top of that, kind of depth of the tree, what do we have on the different levels, and so on, and visualizations and so on. So let's see how far we get here for this. The other thing that Tomasz did, actually, similar approach, but he kind of downloaded the original taxonomy from the organisms, from the NCBI. And this gives you a big zip file with dump files, where their dump files are actually CSV files that are split by a vertical separator. So if you look at these here, for instance, nodes.dump, see that it's basically a file where instead of commas, they use pipe symbols to separate the things, right? They don't have a header, so you don't really know what each column is. It's probably somewhere in the description. And then they have all these fields. So which basically still works, because if we give this in header, then we know this is the ID, this is the parent, and so on, right? So Tomasz has thankfully put together an Jupyter notebook for this to import the data into Neo4j. And that's what I wanted to try doing here with Aura to see how far we get. So we just create an empty Aura instance as such. We copy our password, download it as well, and continue. And this new instance, we call it just Tree of Life. Tree of Life. And it takes a little bit to finish. And while it's doing this, we can look at the Jupyter Notebook. So fortunately, you can open Jupyter Notebook these days in VS Code and just run them in VS Code, which is really useful and nice, right? So I basically just downloaded Tomasz's notebook from GitHub and basically started to run it. So it basically sets up an Jupyter kernel on your own machine, and then you can basically start using it, right? So it just imports graph data science library as a driver, more or less, for Neo4j, Toml because it's needed, and pandas as the tabular data library as such, right? So we import pandas and graph data science here. And here we now have to adjust our connection details. So this is our password, our temporary password. And we need the connect URL. So we can just open our downloaded. There we go, actually. 1 second. I'll just check that. That's kind of when you get a new browser which downloads things into places.
Download something else. Oh, I see. Yeah.
Where did it put it, actually? This one? Here. I need to see where it put it, actually. So anyway, so this is our connection URL, and this connects to our database here, right? So, and if you run this and everything is okay and our database is running, then it complains, oh, there's no GDS running on that database, which is true.
It's true, because it's AuraDB free, it does not have.
Exactly. Okay. So of course the graph data science client does not connect there, but we can probably still use from Neo4j Python driver instead. So let's do this. Neo4j Python driver. Actually, you can in Aura itself, we can just grab this from Neo4j import graph database.
Yeah,
right?
just wanted to say. Yeah.
So, and then we just create a driver and so on. So we just create our graph database. Instead of GDS, we just create a new driver here. For this. URI is host and user and password. And then we should be able to do a driver session run and then match and match and return count star result. So just as a quick check if this is working. And then I think it was it like with begin and end in Python? I always forget the syntax for end. Otherwise, you can just remove this for the time being. Okay, so if you run this, it should driver, graph database driver. Oh, need to rerun this, I think, and then this. And then it should basically work. And then if I do result, result as count, and then I'm not sure, was it result records? Look at, so this is result, and there's a single result single, and then get count, or just count like this, I think. We can actually get the method object is not subscriptable. Yeah, so we have currently no data in our database. So, okay, so we kind of need to figure out the import bit, but at least we got the connection to our database. And what we now can do is basically it reads this CSV file basically with a pipe symbol as a delimiter and uses a tab space because of all these kind of nicely formatted elements that you saw here. Basically, it's basically all, one tab apart.
Okay. Right? Yeah.
So from that perspective, you can just use pandas to load the file, which takes a little bit, and then we just append the columns, and which is kind of taxonomy ID parent, taxonomy ID rank, and so on. And then we just look at the first few lines, and you see that this is kind of our taxonomy, right? So our taxonomy ID parent, rank, comments, names, and so on, right? So no, the names are separate, right? And if you look at how big this is 2.5 million entries, basically, right? So that's quite a lot.
We will have to cut it down a little bit.
Exactly, and that's why we can probably say nodes equals nodes from, I think the syntax was like this. So if you take 1,000 or something like that, or let's start with 10,000, right? So, so now we have 10,000 only, right? So, and here we do again driver session run. Of course, you shouldn't just do driver session run, but for our purpose here, this is good enough.
Why shouldn't you do it?
Because usually you want to, really good question, Alex. So because usually if you run against a cluster, then this function would always go against the leader of the cluster. And if this was a read query, you actually want to distribute it across the whole cluster, and then you would actually use write transactions and stuff like this. But for just creating a constraint, it should hopefully work. So that means if you now look into our database, which we have here, and connect to this database instance, we just have to grab the password from our configuration here. Then we should now see the constraints here as well in query. So show constraints. Hopefully we have our uniqueness constraint for node ID, right? So that's what we just created in our Python Jupyter notebook, right? So that's nice. And now we want to basically take the data and pull it in, right? So what it does is basically it takes all the rows, all our 10,000 rows that we have, And for each of the rows, it creates the node with the taxonomy ID here, and then basically extracts out of the original data the taxonomy ID, parent taxonomy ID, and rank, and kind of skips all these fields that are empty strings or not numbers and whatever, right? So so we can probably skip this because we don't have GDS, but fine. And then it calls an epoch function that turns this rank column, which we saw here, rank, which is, I don't know, rank or super kingdom or genus or species, into a label, right? So we basically add this as an additional label.
Okay.
Is this a genus? Is this a label? Is this a species? Is this the family or so, right? And then basically we can actually return. And because we have only 10,000, we can actually execute this directly. And we just need to see how we turn the data frame into a dictionary, basically. And that's what we would do here with the batch import method. Such. So just let's copy this down here and turn this into something that works with the driver itself. So we get our params, we have our query, our data frame, and our batch size, and we turn this data frame into a dictionary. A dictionary is in Python, it's a map or object, so it's kind of key value records basically. And then we take this for we split this into sections of 25,000 with this batch size, and for each batch data thing, we get this sub-slice basically from the data and run our query. And instead of GDS run query, we just use driver. We can also do it nicer. We say just session equals driver.session. And then we just say with session, so which is kind of we do session.run. And then we run the query, our batch data. And so basically we take whatever we get. So in our case, we have only 10,000 rows here, but for real, it would be like 2.5 million, which we won't fit in. But it would split it up in nice little chunks of 25,000, and then basically run each of them in as one go, right? So let's see if this works or if I made some mistake. And then basically result, we could say again result dot single dot zero is our count, and then we just print this out and say how many results did it create for each batch, basically, right? So it should return now here or print out 10,000 because it has 10,000 in the single batch. So let's see how good my Python skills are.
Didn't create an error, so
not yet. Let's see. But then we should also see the data being added to the
database.
So 10,000. So that looks good. And if we go over to our database, we should now see our node, and these nodes have been added. And you see all these other
10,000 nodes. We see
10,000 nodes and all these other labels that came from the rank entry, right? So remember we had this kind of here species, genus, rank.
And they all
entry,
added,
right? And super kingdom and so, and you see them all popping up as labels. So which is really nice because then you can say, okay, I don't just want to look at nodes in general, but I want to look at, for instance, phylums, which are like then special kinds of plant things, right? So, but they don't have names yet, so which is not so nice, right? So we should probably add names, subspecies, and we also have no relationships yet, right? So we don't have relationships, but we have a lot of nodes. So we probably, so it worked out well with 10,000. So let's say we make it 100,000. Okay. So I just really need to load this file again because I kind of cut out only 10,000, but this is really quick. We had this, and now we have 100,000. Right? No.
Miss a zero, I think.
Yeah, it missed a zero. Okay, let's do this again. Let's do this again. And we get now 100,000 nodes. If I do length of nodes, it's 100,000. We don't need to redo the constraint, but we just rerun the import query. So that means if we refresh here every few times, Oh no, it didn't like us. Result consumed error. Sorry.
Batch data.
Driver session, batch data. It got the data in. And result single of 0. What did it complain about? Perhaps it did not. Oh, node already exists. Oh, didn't it use merge here? Oh, okay. So this is a good example.
Yes. Okay.
So I didn't pay attention, or we all didn't pay attention. So instead of merge, Tomas used create here because he only had one import. But of course, we want to do merge. So when the node already exists in the database, it should actually not try to create it again, but just use the node that's already in the database, right?
Yeah.
Great example of how you shouldn't do it, right? So, and now it should basically give us.
Initial import create is fine because you don't expect to do this multiple times. But if you are want to do this multiple times, then obviously it's not the right one to do.
Right, and now we should get 4 times 25,000,
exactly.
Right?
Yeah.
Right. So we have 2 of them. Now comes the third, and now the fourth, and then we should be done in a few seconds. And that also means we should already see, and now it's done. So in 30 seconds, it imported 100,000 nodes here via Python. And now we see even more labels as such. And so we have a good subset of the data in here, right? So which is
still
nice.
No relationships, but
still no relationships, but we're getting there, right?
Yeah.
So now it because now it creates the relationships, right? So it finds the child with our taxonomy ID from the data, and then finds the parent with the parent taxonomy ID, because that's part of our, as you can see here, is the parent tax ID is basically our parent node, right?
Yeah.
In this column. And so we can, where's it here? We find the parent node, the child node, and basically just create a relationship between child to parent, right? So that's pretty straightforward.
Yeah. Okay.
And we just reuse the batch input function that we just added here. And so from that perspective, let's see what happens. So we take our nodes and just extract the subset of just text ID and parent text ID. And then we see there is an error because it didn't get any results back, which is interesting. So if see pound equals result single, if not pound is so, just put this out into a separate cell. Add code, and then we try this again. So because we didn't, you know why? Because we didn't return count here. That's kind of.
Yeah. Okay.
That's the reason.
It just creates relationships.
Exactly.
So just so we understand, it looks at a node and checks for the ID and finds this other ID that is written there in the parent text ID, and finds this other node and then makes a relationship between the two.
Exactly. So when we go back to our database now and refresh this, it should have parent relationships. See?
Yeah, nice, perfect.
And now we have our nice little graph here, and so which actually also should allow us to let's just refresh perspective here as well. And now we should actually be something, if we say show me a graph, it should show us a little graph, and we can select everything and say expand to parent, for instance. And so because we want to look at a tree of life, we can actually go with the hierarchical layout. And now you see basically here the hierarchy. It's only one level hierarchy right now here, but you see, I think over here it's probably a little bit deeper.
Yes.
right? Because it goes like a little bit deeper or so.
Yeah.
But you see that here, for instance, you have like already like a 3-level hierarchy. So if you had imported more nodes or more nodes whose parents were in there or so, then we could have seen more of that. And actually what we could do is kind of, we could also see, if I clean out the scene here, we can also just say, give us like a 5-level it doesn't like me. Not so much there in database, it should just do it.
What is it you want to do now?
I want to do like 5 nodes in a sequence, basically.
I see. Yeah.
All right.
Okay.
So
like
I want to do node, basically. Not sure why it's what it's doing. For whatever reason, it doesn't like me so much today. But we can also do it just in Cypher, right? So so if you want to start at a node, and then this is our root node, and we say this is our parent relationship, and we want to have 5 levels deep, right? So we want to get everything that's 5 levels deep from this node. This is our child node, and we assign everything to a path. And we return our path, and let's say limit 200 or so. So this should give us, hopefully, really nice.
Let me see a few. Yeah.
As you can see here, a really nice kind of tree where we can also zoom in. This is kind of our root node here, right? And then you see all these other nodes that are 5 levels away from this root node, and you can actually look at. So this root node is some plant, and we still need to add the names. So we don't have names here. So that's where we go back to our Jupyter notebook, actually, and import the names. And so because the names is basically similar, we have a names dump file here that we can just read in, which it just did. And then we basically go over the names and look at them as such. And you see now the taxonomy ID has a name like bacteria or eubacteria. And if you go further down, so for instance, if you say, if you add this, you see that it goes all the way to a certain specific bacteria, for instance, right? So you see the taxonomy ID gets then down, and then we see these, right? So that means we can now add the names to our nodes, and that basically we could limit it, but I'm not sure if they're ordered in the same way. So I could actually, let's try this if this is good enough. I mean, just say names equals names from 0 to 100,000, right? So, and let's hope that they're ordered in the same
you think
way.
Okay, well, we can try.
If not, we have to pull through all the million, 2.5 million, but that takes. So this time we add our count, that we don't forget it again, and it basically takes again batches of 25,000 and basically just takes the taxonomy ID and the name text and sets this as a name, right? So and if you run this, it should be pretty straightforward. Just find the nodes, but it doesn't. For whatever reason, it's not our friend today, so it doesn't connect.
What did it? How did it lose the connection?
It doesn't collect anymore, but here it says that it's still running.
But the URL was wrong. The URL was wrong. It's
it's the wrong. This one.
I don't know where. This is not the right one.
Okay, then let's just reconnect the driver and try again.
Where did it get that URL from? Is the question, really?
I don't know. So we got. So it also now shows us that it's not 0 nodes in the database, but 100,000. So which is also good, showing us this. And we wanted to import the names. Here we are. Let's put names again, and basically let's get 100,000 nodes, and then we basically fetch this through, and this time it should work.
Fingers crossed.
Yep.
It seems good.
Yeah, I think I need to fix the. Okay, it should say count of 0, right? So.
Okay.
but it's fine. It's still done, right? So
we
can also run it. We can also run it again.
No, it's fine.
Because it's idempotent.
Okay. Yeah. Okay.
So that means if you go back to our database here and rerun this again, our statement, now all our nodes should have a name, which is really nice, because now we can basically it should have a name here, right? So we can also change the setting here for the visualization and say name here, right? And now we should see when we scroll in basically what the name of the nodes is, right? So I can probably, for the phylum doesn't have a name. That's weird.
Yeah, but we tried. You remember?
Yeah, we only took
the
a
first 100,000, so maybe.
Yeah, so we can probably let it just run in the background and do it all, basically, right? Because it can just run in the background, and then you run this again. No, we don't want to take a survey for VS Code. Thank you. And then we just let it run, so it will run a lot of times, but in the end, we'll get some more data here. But at the same time, we can also look at our Explore again. And if you refresh perspective here, you should also see now our names being added. And then we can also add here as text our name as well, right?
So maybe from a quick question from Eshwa, on the CSV file, do we have to check the null values and duplicates to rectify that we have read the files correctly, or don't we have to do this?
It does it kind of automatically, right? So if you look at our statement here again, it imports the CSV file. And then what we do here is we just, from the file values, we only take the text ID, parent text ID, and rank columns anyway. And we already skipped the empty values, right? So, so we could actually, we ignore all the other values as well, right? So, so the only thing that I didn't do is not a number, because then I need to put in, I think it's epoch util, not a number or something like that. Let me just check. Call epoch help an. See, not a number. Thought we had a function epoch for not a number, but perhaps I was mistaken. Anyway, so but you can pass in the values that you don't want to get. For instance, if there's like a not available or something like that in here in epoch map clean. So epoch map clean is a pretty cool function. You just pass it a record or a map, and you say, I want to have these fields. I just want to keep these fields, and I want to ignore all the ones that are, all the values that are empty string or not a number or zeros or whatever. So it gives you like a cleaned out version of the data, right? And then basically we just create a node from that, and then just set the labels on top of that, such. So it's pretty straightforward as such. Super. And now it went through and did a lot of matches and or not, right? So you see the last few didn't get any matches as such. But it's done now after a minute, right? So even 2.5 million rows. And all the 2.5 million rows have actually been sent to Neo4j, then checked there, and then basically updated the graph as well, which is actually quite nice, right? So we now have.
If we take,
So go ahead.
Continue.
Alex.
No, it's okay. Yeah, I was just saying, if you go to the previous screen, and if you were to rerun this, you would see all the names now in.
Yeah. We can do this in a second. I just wanted to show you, if you have this kind of little tree here, right? And if you select everything and then say just expand parent relationships, but there are not so many here that come from here, right? So that's our mini tree here that we can see bacteria going all the way down to stigmatella and neococcus and Myococcus something else, right? So you see they've also been discovered in 1892 as well, right? So it's and because it's 2.5 million nodes in total, so there's like a lot more data in here, right? As such. But what we can now basically do on top of this is basically say, okay, if we want to explore this data, so let's go back to Marsha's blog post actually, which is this one.
Yep.
So we imported the names as well. I'm not sure if there was anything else that Tomasz imported here, or hosts. Actually, I don't know what hosts are. Organism hosts.
Oh.
It's probably, perhaps kind of who can host like a virus or whatever, or like a human.
I see. Okay. Like
so we could do hosts and then citations, which would then also pull in papers and things like that, right? So you can basically pull this in. You probably don't need to go there, but you can take the notebook from Tomasz's GitHub as well. So basically he added just potential hosts and the citations for the papers where these specimens have been discovered as such, right? But what I want to actually do instead is look at some of the queries perhaps that we can run on top of this.
yes.
So you have like nodes with parents, citations, and nodes in the end, right? And so what can we do now? We can run this against a human, but I'm not sure if you have a human in there. So let's see
if we have a human. That's the question.
I don't think so. Oh, we have a human. See, and there are Neanderthals and basically modern humans. Oh, actually, it's like this, right? So we have basically like this, and then we have Neanderthals here, right? So so of course we didn't import all the data. That's why probably modern human is not in here, but you see like
they're missing a few links.
Right. So but you get the idea, right? So usually you would have a full tree. So we could also have imported 200,000 nodes, but then it would have ended because that's the limit of AuraDB 3 as such. So we get roughly 10% of the tree of life in. The other thing that we could have done in the Jupyter notebook is basically pre-filter by names. So we could actually have imported something where we pre-filter by name or genus or something like that, and then only import those.
Then only do this.
In pandas, in pandas we would have pre-filtered stuff, and then basically only inserted into Neo4j what we wanted to get in. Right? But let's see what else we can do here if these are also working. Oh no, sorry, that was Pias. I just need to look at the right number of species, human parents. So you see basically how it goes back from human all the way to the superclusters and so on, right? So I'm not sure if this gives us a lot of data here. You see only human species and genus and not the other ones because we haven't imported them. But there are also other things where we could kind of find the shortest path between two species basically as well. So this doesn't show us anything because we don't have the data as such. But in Explore we can do the same. So we can also say just show me a graph basically. Or we could actually let's say just to demonstrate what shortest path looks like is let's take this node and this node over here, these two. Let's dismiss all the other nodes. So we have two nodes left. And then we want to see the shortest path between them, right? So that's basically gives us then the shortest path between these two. And so you see basically here really nicely, it goes all the way up to the parent and then down from the parent again.
Now we had a short lag. Can you show again where you clicked for the shortest path?
I'll do this again. 1 second. I just I select these two, I dismiss all the other nodes, so I have these two left, right?
Yep.
And then you go to path here.
Exactly.
And then shortest path.
Here I see it now. Yeah.
And this gives you basically the shortest path here, right? So which is really nice because now, especially in the hierarchical layout, it looks really nice in terms of the right? And then you could do also similar ones between other. Imagine you had imported everything. You could say, what's the shortest path between human and some other,
sea urchin.
Sea urchin, exactly, or like banana or something like that, right? So what's the shortest path between human and banana, right? So, and Or here, as Tomasz had it, between an orange and a banana, right? So you basically see here's the banana, and it goes all the way to an orange, basically. So it's actually pretty far, even if you often have them together in fruit baskets as such, right? And right. And you can also go from one node to the parent, so that you go to the family. So we can also basically just say, if you go to query again, if you don't have sweet bananas, then we can take something else. Or we can just say, give me, see, we even got this sweet banana somewhere, right? So, and then you get basically to the parents. And you see this is kind of an open length variable path, so it can be 0 hops apart, but it could also be 500 hops away, the family of the sweet banana, right? And then you go from the family to the genus one node up as such, right? And then you have this as such.
So the green one is the family.
The green one is the family, and the brown ones are the genus. But it didn't. Tomasz didn't return the original path from the sweet banana to the family, but only from the family to the genus. But if we also assign this to, for instance, P0 here or something like that, and we return both, then we should actually see full tree, right? So we have like, here's our sweet banana. It goes to the the genus, to the family. So you see that we have 2 paths here that we can express. We could also pull this together into one, of course. You could also just say something like this here, right? And then just call it path. Oops. So depending on your query, it's easier to read or not so easy to read, but then you can also just run this as well.
Yeah, sometimes you're
and
right.
You should probably also. But
no, it gets a little bit. If you trunk it out in two lines, it's sometimes easier to understand and easier for you to understand afterwards. If it's not this one bigger connected path. But it's totally possible.
Exactly. And something else that I wanted to show you really quickly. So you see that it takes quite a bit before it returns the results, although it's just a little bit of data, right? But if you look at the explain plan here, which is now added to query, you see that it does a full database scan for the sweet banana, right? Because we hadn't created an index for the
they have no index on names. Totally right. Yeah.
Exactly. So we just create. We can actually do
so remember, index. Everybody, we only created an index on ID numbers, so which we needed for the names. But now nobody, I guess nobody would search for ID numbers. I mean, only if you are a computer. As a human,
exactly, if you're an API or something like that, then you would do the ID, right? And so now we can create a text index for node on name, and it should create a text index for this, which it now did. And if I rerun our query here, it should now, hopefully. No, why didn't it do this? This is interesting. Why did it not?
Does it need to refresh? No.
Should not. No. Leave it. Okay, let's run the explain again. Okay, now it does.
No.
Perhaps it took a second or so. Now you see it uses the text index for the name here, right? So and actually, if you run it with profile, we see it also that it should return just one element here, and then goes from the banana all the way to all the families, and then from here to the genuses again. Right. So that means in principle it should also be faster to run it. I'm not sure why it still takes 300 milliseconds here or whatever it is.
Can we compare? How long did it take before the?
Yeah, now. Yeah, we need to drop the index again. So now it looks better.
Did you scroll down? Did you close the window?
Something is weird. No, I just ran it in the same window.
You closed it?
Time and again. So. I didn't close it. I just reused it in the same window.
Yeah, you reused. Okay. Okay.
Yeah.
Well,
okay, but that's something that definitely makes a difference, right? So if your code is slow, then perhaps it's just because you didn't have an index, and then it basically needs to scan the full database as such.
Yeah.
Cool. And to close it off, You can also do parasite detection. So we didn't import the hosts, as we said, right? But you can say
no, we did not
who
do
can
that,
be a host for a certain parasite and things like that. Or you can also look at papers and authors. So which authors talked about which parasites and things like that as well, right? So that could be something where you, if you go into pandemic and look at monkeypox or chickenpox or something like that, or chicken flu or so, then you can basically see who are potential hosts and which hosts basically are related and things like that. How far are the hosts from each other and things like that, right? So you basically can see that as such, and then basically go down from a host down all the way down to the species as well, right? So then you can see which species are actually potential hosts for this virus, right? And so if you want to play around with the data, Tomasz also provided a full database dump. I'm not sure how big it is, but it's probably pretty big. Let's see, 174 megabytes. So you can basically also import a dump into your Aura database, but not into AuraDB free, because that's a little bit too many nodes and relationships.
But you could get Neo4j desktop, which gives you also an enterprise edition we install locally.
Exactly.
You
can get a bigger instance as well on Aura as well, right? So you can also just get a pro instance and then take an 2 gig or 4 gig instance and import it there. But if you want to play around with this, Tomasz has it all there. And similarly, for Priya's example, the huge XML file, you can basically import it as well, and then you can do similar explorations. It seems that the XML has much more detailed data, as you can see here. So like containing groups, subgroups, and so on. You have even links to links to places and so on. So there's a lot of stuff in there as well, right? So there can be much more data imported here too. Right? So so that's another good article that we can probably also share as well.
Put it in chat. So I'll put it in the video description as well.
I'll put it into the chat. This is Priya's article, and this is Tomasz's article here. And the Open Tree of Life is down here, which has also the links to the visualization as well. Here where it says view the new version as well. So that's also something. Right. And if you're interested in this topic, feel free to play around. Let us know if you found something interesting. Of course, you can now, for instance, imagine building a new dashboard on top of that and basically have the user interactively explore the data without having to write cipher statements or things like that. So there's a lot more possible. And actually, I'm happy that we got it to run, even if you had to kind of change Tomasz's notebook a little bit. But it also showed you how to import data with Python and Pandas, which is something we should probably do more anyway in the future to show a little bit more coding.
I think that's a good. Let's maybe do this in another episode in a bit more detail how to get going with a Python notebook. I think that's a good suggestion. Seems to be lots of questions around the topic usually.
Yeah, exactly. And it's not hard, right? So you can just open the notebook in VS Code or in Google Colab, and then just use the Neo4j driver and connect to the Neo4j database, and then basically get going as well. Right? Yeah. So it's pretty straightforward. And you can just run your Cypher queries, and then if you have graph data science installed, you can also run, for instance, something like clustering or centrality procedures as well, or metrics on top of that as well, right? And this is actually really interesting, really fun data set, and I'm really happy that we got it to work. Nice.
Yeah, no, it got to work. Yeah, thank you, Bench. They say thanks for interesting use of Neo4j with Python. So you're welcome. Thank you for the feedback. I think that's on the dot almost at the hour. Yep. So I think we perfectly landed there. Thank you very much, Michael, for this today. Again, the recording is available on YouTube. So if you don't have not subscribed yet, then please subscribe to the channel. Ideally, you do this on YouTube or on Twitch, so you get the notifications when you are wanted to see when we're live next. And this week is another busy week of interesting discussions and live streams around Neo4j. So today, obviously, we had the Discover Neo4j AuraDB. Tomorrow is break. On Wednesday, I'll talk with Jesus on Going Meta, episode 15. And on Thursday, episode 15 is amazing. And on Thursday, a brand new episode, brand new series is kicking off with Michael. Michael talks to ChatGPT for discovering, for actually developing graph applications.
For coding, exactly.
Coding, yes. Yeah.
So I want to see, so my goal is to write in Google Chrome extension that can take text from a web page, send it to GPT for entity extraction and graph extraction, and then send it to Neo4j to build up a knowledge graph. So let's see how far we get. And because I've not written Chrome extensions before, or haven't used the GPT-4 APIs themselves before, let's see how far we get with that Chrome extension. And of course, we'll have GPT-4 help us doing all the work, basically. So I'm just the typist that turns recommendations into code. So let's see.
Cool.
And I want to try some new technologies that I haven't used before and see how well like a large language model can help us learn new stuff and try out new things. And that, of course, also where it goes wrong, right? So definitely not everything will be rainbows and unicorns, but it will be interesting.
Same, but that what happened. But that's I think the beauty of it, and I think it's a cool concept, a very interesting idea. So I'm looking forward to watching that. So if that's something you're interested in, come on Thursday and see where Michael lands up and bring maybe you have some suggestions as well and help out.
Bring some popcorn.
With the popcorn.
Exactly.
Yes. Yeah.
Exactly.
We'll be taking a break next Monday. So if you're wondering, next Monday is no episode because
and actually other Monday too.
Holidays.
Monday in 2 weeks as well. So because I'll be traveling
Monday 2 weeks as well. Okay.
So I'll be going to London and
Oh, you're going on a train to London? Okay, that should be cool.
It's a nice
maybe we do
train ride.
Oh, maybe we should do a stream next time on this.
And we can do a stream from the train, so that would be fun to
Yeah, maybe. All right. Well then, have a good rest of your week, everybody. Hope to see you on one of the live streams we are hosting. If not, then have see you another time. And I guess with that, take care, everybody, and happy graphing.
Yeah, take care, everyone. Bye-bye.
Bye.